There we go. So welcome everybody to today's online maths tutorial. We're going to be covering perimeter, area and volume. So obviously that's quite a big topic to cover in one tutorial. We're going to have a bit of an overview of each part, but then as always we create each tutorial on the back of questions asked by learners and patterns that I find when I'm marking things like practice tests that people aren't quite understanding or getting right. So if you want to focus on any of these areas, we can always focus on that on the next tutorial as well. So maybe we could look at volume next week, for example. We'll always create the tutorials but on the back of what you guys need. So as I said, today we're going to be covering each part. This covers level 1 and level 2 maths learning. Perimeter covers in both level 1 and level 2. The difference between level 1 and level 2 when it comes to perimeter, area and volume are the shapes. So at level 1, you'll be working with shapes that have straight edges and corners. So squares, rectangles, cubes, that sort of thing. At level 2, it's then increased when you're looking at curves and circles. That's when pi comes in, for example. So if you're doing a level 1 qualification, don't worry about anything that has a circle on it. Obviously, you might then progress to level 2 eventually. So you can still take part if you want to. But if you're doing level 2, all of this will be covered at level 2 as well. I've also included a handout today you should be able to see a handout just on the left hand side titled Formulas, and I will go through that with you at the end. I can also send it on an email as well if you don't have access to the handouts or can't find it in here. But basically that has a list of all the formulas that you need to memorise that wouldn't be given in your exam. Some of the more advanced formulas will be given to you, but some of the formulas, as I'm going to go through with you at the end, you will need to memorise ready for your exam. So as I said, we're going to cover perimeter, area and volume today. We're going to start with perimeter. So perimeter is a distance all the way around the edge of a shape. Perimeter is a length and is measured in kilometres, metres, centimetres and millimetres. To calculate the perimeter, we measure all the sides of the shape and add them together, remembering that all the units must be the same. So as always, we've got a couple of examples for you. So here's a square. So obviously a square has 4 equal sides of length. So to calculate the perimeter of a square, we add up all the measurements of each of the sides and then add them together. So we have each of the sides worth 10. So in total, the perimeter of the square is 40 centimetres. Now, at any point, if anybody's got any questions, just drop it in the chat box. It might be a question that somebody else is wondering as well, but don't quite want to ask it. So feel free to ask any question, even if you think it's a bit silly or simple. It won't be, and I can assure you that somebody else will probably want to be asking the same question as well. So that's the perimeter of a square. If we move on now, we're going to rectangles. So similar to a square, but obviously this time the opposite sides of a rectangle have the same measurements. But just like a square, to calculate the perimeter, we add up the lengths all the way around the edge. So in this example, we have 8 plus 4 plus 8 plus 4 to give us 24 centimetres. And luckily, the measurements all the way around this shape are all the same unit. They're all in centimetres. So the next one, I'm going to look at mixed units. So as I mentioned, we add up all the measurements around the side of the shape, but we have to make sure they're all in the same measurements. So in an exam, you might be asked to calculate the perimeter, area or even volume of a shape that has mixed units. So have a look at the unit the exam paper would like you to answer it in. It's often easier to convert your measurements to the same unit. This can ensure your answer is in the right unit as well. So in this case, for example, you need to convert each of the measurements to the same unit when we're doing the perimeter. We could convert the centimetres into metres and make the measurements all the way around metres, or we could convert the metres into centimetres and then add all the amounts around the edge of the rectangle together in centimetres. Now, because the answer needs to be in centimetres, it's a good idea to convert it into centimetres and work in centimetres all the way through, because that will ensure that you do give the answer in the right unit. So in this case, I would convert 1 metre into centimetres, so I've got 100 centimetres. The opposite side will also be 100 centimetres, and then we've got the 240 centimetres as well. So we end up with 280 centimetres in total. As I said, we could have converted it into metres, but you do then have the short issue, just in case you forget to actually convert it to centimetres in the end. Always look at what the answer would like you to answer in, and I'd suggest you always work with that unit. Anybody have any questions so far? If you just put a yes or no in the text box, that's really helpful, then I know that everybody's okay. No? So we're all okay, no questions so far. Fabulous. If you ever have a question, don't wait for me to ask. Just pop it in the text box, okay? So the next thing we're going to look at is composite shapes. So you might have seen composite shapes in your learning, and they quite often come up in your exams and your practice tests. Composite shapes are shapes that are made up of two or more individual shapes. So commonly found in level 1 and level 2 maths exams, and could be shown as the shape of a garden or the plan view of a house, for example. Its perimeter is found by adding the lengths of all the outside edges. So there's 4 examples on the screen of some composite shapes there. When we look at this at the beginning, particularly if we're asked for the area or even the perimeter of the shapes, it can seem quite daunting. But all we need to do is split up these composite shapes into shapes that we do recognise. When we're looking at the perimeter of a composite shape, it's much easier because you probably will have the measurements and you just need to add up and make sure that you've added up the lengths of each of those sides individually. So like with the arrow, the first one pointing up there, there's 1, 2, 3, 4, 5, 6, 7 different sides to that shape in total. So you should have 7 different measurements to add up all together. We're going to look at the area, the volume of some composite shapes as well. You might also have a composite shape, for example, that has missing measurements. So when I say missing measurements, you might be asked to calculate the perimeter of a composite shape, but they might not give you the measurements of all the sides. So you need to not only figure out the perimeter of the shape, you also need to calculate or figure out those missing lengths as well. So I've done this one on the board as well. I'm hoping you can all see this. So this is technically a plan view of a house. And the question is, we need to calculate the perimeter of the kitchen to find out how much skirting board we need to order. So that's the kind of question that makes it functional. And that's the sort of questions you'll probably have in your exam. It's functional because it's true to life. So you've got a plan of a house and you need to figure out how much skirting you need. So we'll talk about skirting. It goes all the way around the edge of the room. So we're looking at the lengths all the way around. Well, I've got some missing lengths there. So we're missing length A and B. We need to calculate those first before we then add all the measurements up to calculate the perimeter. So if you look at measurement A first at the top, to calculate that, we need to look at the opposite length. So if you look at A, we're not sure how long this is, but we do know that the length here at the bottom is 300. And we know here, this measurement is 150. So we know that from here to here is 150. Therefore, if we take 150 from 300, what we have left here should be 150, which is this measurement here. So A should be 150 centimetres. Just like that. So I'll go through that again briefly. We're looking at this missing measurement here. We need to look at the opposite side. So imagine this was a square. If this carried on, the length would be 300, just the same as the opposite side. We know that the measurement up to here is 150. So what's left here, which is exactly the same length as A, would be 150 as well. More beaters on the case. Then we're going to look at length B, so wall B. So again, we look at the opposite measurements. I'll put the measurements up for you. So if you look at wall B, we know that the opposite wall is here. We know that the length of the entire of the opposite wall is 400. We know that this one is 200. So if you imagine the line went all the way up, this would also be 400. So up to here is 200. So what we have left is 200 again. So we look at the opposite sides to calculate the missing measurements. So we've ended up with 200 centimetres for B. Is everybody okay with that? Any questions at all? Anybody want to have a go at calculating the perimeter? You okay with that one? I don't think I actually calculated the perimeter at the end of this one. I was just looking at the opposite sides. Anybody want to have a go? Just be said, well, she is right, it's 1400 centimetres. So the length of all the measurements all the way around this kitchen is 1400 centimetres. So that's how much skirting we would need for the kitchen. Now, we're going to move on to circles. So measuring circles. I've moved on to circles because we're still looking at technically the perimeter, so the distance all the way around the shape. But with circles, we actually call it the circumference. So we use the term circumference when talking about the distance around the edge of a circle. The circumference is just like the perimeter, but it's only used when talking about circles. Okay. So parts of a circle. So the circumference is the distance all the way around the edge of a circle. We then have the diameter. The diameter is measured from one side of the circle to another. Obviously, it always stays the same. Don't matter where you measure it, it always goes through the middle. And the radius is the measurement from the centre of the circle to any point on its edge. So in this case, for example, here is 50. Like I said, it doesn't matter where you measure it, it's still going to be the same distance from the middle of the circle to the edge. So we have the circumference, we have the diameter that goes all the way across, and we have the radius that goes from the centre to the edge of the circle. Now, pi. Oh, I don't think those images have come across very well. Pi is a number that is used to represent the ratio between a circle's circumference and its diameter. So pi is used in every formula where we are trying to work out the size or shape of a circular object. In functional skills, we tend to use pi to 2 decimal places, 3.14. Some occasions on your exam, it might ask you to use 3.142 or 3.141. But we just need to read the question carefully and see exactly how much they would like you to use for pi. But pi is actually infinite. As you can see in that circle, it goes on and on, 3.1415926535889, and so on. When I was at school, I was taught it's 3.142, or as a fraction, it's 22/7. So we're going to be using pi now. We use pi when we're referring to circles. To calculate the circumference of a circle, there are 2 formulas we can use. Circumference can equal pi d, so again 3.14 times the diameter. And if you remember, if you attended the formulas tutorial, if you have a formula that doesn't have an equation in there, it's always a multiplication. So pi d means pi times diameter. Or we can calculate the circumference of the circle using its radius. And the formula for that is 2 pi r. So 2 times pi times the radius. This will need to be memorised for level 2, the circumference of a circle. But it doesn't matter which one you use. I tend to use pi d, some people use 2 pi r. It doesn't matter. So the circumference using both formulas. So the first one is an example using pi d as a formula. We have a circle on the screen. It has a diameter of 6 centimetres and therefore a radius of 3, because the radius is half the length of the diameter. So if we calculate the circumference using pi d, it would be 3.14 multiplied by 6. Anybody want to give me the answer there for that one? Does anybody have the answer? Yeah, you're right. Well done, Chloe. 18.84 centimetres. Now, the other way to do it, as I mentioned, there's two different formulas for the circumference of a circle. We have 2 pi r, so that would equal to 2 multiplied by pi, which is 3.14, multiplied by 3, which is the radius. Anybody want to hazard a guess on what the answer is? It would be, yeah, Kim's right. Yeah, it would be just the same. The formula is just the same. It gives you the exact same answer. It doesn't matter, just to confirm with you, it doesn't matter which formula you memorise for the circumference of the circle, they both work. Whichever one sticks in your brain more than the other. I use pi d because it seems to have stuck in my head. Obviously, I can calculate 2 pi r, but you need to remember one of these for your exam, just in case you ask for the circumference of a circle. So try and memorise one of them and make it stick if you can. You'll get the same answer, it doesn't matter which one you use. So I've got an example now of calculating the circumference of a bathroom mirror. So again, I've used a bathroom mirror because it's a functional example. You normally get examples of day-to-day life things in your exam. So does everybody want to have a go at calculating the circumference of the mirror on the screen? It has a radius of 50 centimetres. I'll just give you a minute or so to have a go at that. Just drop me a chat when you're ready. Fab. Kim's got an answer. Yep, you're all doing really well. I've used pi d as the example here. But again, this question could come up in your non-calculator paper or your calculator allowed paper. You can get questions on circumference, area, volume, perimeter in your non-calculator paper or your calculator allowed paper. The difference would be the numbers used. So this is a much more, especially at level 2, it's a much more friendly calculation to do without a calculator, because you can move the decimal place 2 places because you're multiplying by 100. So I'll just go through it on the board just in case anybody needs me to. So we can use the formula pi d to calculate the circumference of the bathroom mirror. If you remember, it's the distance all the way around the edge, right to the same point again. So pi d would be 3.14 multiplied by the diameter of 100. And if we're multiplying by 100, we can move this decimal point 2 places to give us 314 centimetres. Or if it was in a calculator allowed exam, use your calculator, just to check that you are correct. Any questions? Everyone okay so far? Don't worry if you do, and I can go through anything again. Yeah, Chloe's just mentioned she finds this bit easier than working composite shapes for some reason, but I totally understand that, because when you, as I mentioned, when you look at a composite shape and it appears on the screen or in your exam, you sort of go, oh my gosh, how on earth am I going to calculate that? But I'll go through some composite shapes with you shortly as well, to help you figure those out. But if you can figure out the perimeter or the area or the volume of an individual shape, a composite shape is just seeing that shape as the separate shapes that you're aware of, calculating each of them separately, and then adding it all together at the end to make that whole shape, whichever one has been used. Oh, I've added the 2 pi r version as well there, but again, obviously it's the same answer. 2 times pi times 50 to give us 314 centimetres. So we're going to look at the circumference of a semicircle now. Natural progression from circles. You can be asked about semicircle, and I think there are some questions in BKSB in your learning that cover semicircles as well. So a semicircle is half of a circle. To calculate its circumference, we simply halve the formula for a full circle and then add the diameter, this length here. So let's imagine this is a swimming pool. Would be nice, wouldn't it? We had a swimming pool that was a semicircle. We needed to calculate the measurement all the way around here and then across here as well. So it's the circumference of the semicircle is the distance all the way around. So we would do that by calculating the circumference of the full circle. So we're using 2 pi r or pi d. We then half that amount to figure out this part, and then we add this bit at the end. So I'll calculate it for you and with you. If anyone wants to have a go, obviously, as you're going along, feel free. Oh, sorry, I'll just stop. Sorry, guys, everyone's saying there's loads of noise in the background. Thank you. Sorry, guys. So I'll go through that again. So this is the circumference of the semicircle. We're going to calculate the distance of the full circle, then chop it in half to give us the semicircle, and then we're going to add this distance at the end to give us the full semicircle shape. So we're going to use pi d. So we'll end up with 3.14 multiplied by the diameter. In this case, it's 10 centimetres again. Give us 31.4. Okay. We then half that. So that's the distance all the way around this full circle. So 31.4 divided by 2 is 15.7. So 15.7 is the distance from there all the way around to there, this half circle. So do you see how we've used the formula to calculate the circumference of the full circle? We've then halved it to give us this distance here of just the semicircle. And then because we want the distance all the way around this semicircle, we then add this length here. So 15.7 plus 10 is 25.7 centimetres as the distance and the circumference of that semicircle. Is everyone okay with that? I can go through it again. Just drop me a yes or no or a question if you want to. Fab, got some thumbs up. Just ask me a question if you're not sure about anything. We're going to move on to area next. So let's look at area. So we're looking at the area of a few different shapes. We'll start with a square, then a rectangle and a circle, just like a different perimeter. So the area of a square, the area is the measurement of the surface of the shape. So we'll just look to the circumference, which is all the way around the edge. But the area is this bit in the middle. So if you were to paint a wall, for example, you'd have to calculate its area to know how much wall needs to be painted. So when we're looking at the area of a square, the formula is base times height, and again, you will need to know that for your exam. It's always shown as squared. So as you can see in this example, the area of the square is 10 multiplied by 10. With area, it's always to the power of 2 or squared, your answer will be, because we've multiplied two different measurements together. So the answer to this question, the area of this square is 100 centimetres squared. So we multiplied 10 by 10 to get 100 centimetres squared. It's the exact same measurement, the formula for a rectangle as well. So the area of the rectangle will multiply the base by times the height. Just be sure that the measurements are in the same units. We don't want to be multiplying metres and centimetres because you'll end up with an amount that's totally wrong. So as long as we're all in the same units, In this case, we multiplied 15 centimetres by 10 centimetres to give us an area of 150 centimetres squared. And as I said, it's squared because we're multiplying two different measurements together. Now, we're going to move on to the area of a circle now. So, as I mentioned before, when we're looking at circles, we always use pi. The formula for the area of a circle is pi r squared. Is pi r squared. So the amount I've used for pi here again is 3.14. The radius of the circle that's on the screen is 5 centimetres. And again, the answer is squared as mentioned. So to calculate this one, I'll show it on the board. I don't know if you can see this now. So it'll be 3.14 multiplied by 5 squared. Now, if you remember with your formulas, if you remember BIDMAS, it's always a good practice. It will probably still work out the same, but it's good practice to remember your BIDMAS. So brackets, indices, division, multiplication, addition, subtraction, to do your indices first. So I would put that in the brackets. I'll calculate the indices first. So 5 squared is 5 times 5. So you end up with 3.14 multiplied by 25. Anybody want to give me the answer? I'm at betas on it already. Fabulous, well done everyone. Yeah, it's 78.5 centimetres squared. And again, because it's an area, we've multiplied two numbers together at this point here. So it ended up with 78.5 centimetres squared. Quite often in your exam, your measurement and the squared will be there. Sometimes it isn't. So especially if it's a multiple choice answer, you make sure that you do answer using the correct measurement and it's squared if you've worked out the area. Next we'll look at triangles. So the area of a triangle, to calculate that, is base times height divided by 2. Again, you'll need to know this for your exam. So to calculate the area of a triangle, we multiply the base by the height and then half it. So in this example on the screen, the base of the triangle is 8 centimetres. The height is 5 centimetres. 8 multiplied by 5, what's this? 8 multiplied by 5 is 40. 40 divided by 2 is 20. And again, it's squared. Centimetres squared. Because we're working out the area, we've multiplied two different measurements together. We've halved it because technically a triangle is half the size of a square or a rectangle. So that's why we half the formula, which would have originally been for the base times height is the formula for the area of the square or the rectangle. So we half it because we've actually got a triangle now, which is technically half the amount of a square or a rectangle, depending on its measurements. Any questions at all? I'm going to move on to a composite shape next, just for Chloe. Are we all okay with that? Yeah. Brilliant. Just pop a question in if you need to. I can go back on these slides whenever we need to, okay? So, this time we're going to look at the area of a composite shape. I am nothing if not prepared. So I've got the composite shape on the screen and on the board so we can work it out together. So this is a composite shape because it's made up of two different shapes that we recognise. As you can see, we have the rectangle and we have a triangle. So you might be asked to calculate, this could be, for example, the shape of a garden or something, and you need to calculate the area to figure out how much turf is needed, for example. So to calculate the area of a composite shape, we split it up into shapes that we do recognise. We then calculate the area. So we've got the rectangle first. So to calculate the area of a rectangle, we know how to do that. We also have a triangle. To calculate the area of a triangle, we know how to do that. So we do each of them, and then we add them together to get the full area of this arrow shape. So for the rectangle, it's base times height. So we've got 3 times 9 gives us 27. centimetres squared. For the triangle here, there is an additional element to it as well, because we need to calculate the area by multiplying the base times the height and then dividing by 2. Now this time we know the height's given is 5, but the base here is slightly off because we have a measurement of 1 centimetre, if you notice, just there, nothing here and nothing across there. So we need to use our knowledge that we went through right at the beginning to look at the measurements that we do know. So we know from there to there is 1 centimetre. We know by looking up here that the distance from there to there is 3. And the distance from there, just the same, is 1 centimetre. So the base of this triangle is 5 centimetres in total. We just added each of those up. So what we end up with for the triangle is base times height divided by 2. So 5 times 5 gives us 25, then 25 divided by 2 to give us 12.5 centimetres squared. Then we add those two totals up. So we've got 27 centimetres squared for the rectangle and 12.5 centimetres squared for the triangle. Does anybody want to let me know what the area would be in total? Thanks, Peter. We all seem to be in agreement. Fabulous. I'll just give everybody a chance to have a go as well. So we end up with 27 plus 12.5 to give us 39.5 centimetres squared. So we've calculated the area of that funny looking shape, the composite shape, by splitting it up into shapes that we recognise, then applying the formulas that we know to calculate the area, and we just add them together. Even if there was another random shape up here, another triangle for example, we could just add triangle, rectangle, add them all up together. Chloe, do you feel okay about the composite shapes a bit more now? Anybody have any questions at all? Yeah, it all comes with practice. And once you've got a bit of confidence in the individual areas of shapes, you'll then find it much easier to look at a composite shape and not get so sort of scared by it and the sort of unfamiliar, weird shape that it is. Yeah, and there's some of the missing parts. But if you know how to calculate the area of the individual shapes, you will soon recognise those missing elements that aren't allowing you to calculate it in the way that you know you should be doing. Right, so what we'll do now, we are going to move on to volume. Hopefully everybody's okay so far, but as I said, just drop a chat in the box if anybody needs me to go back over anything. So volume is a measurement of the space enclosed in a 3D shape and is measured in cubic units, for example, millimetres cubed, centimetres cubed, metres cubed. So you notice in volume, everything is cubed or to the power of 3, because we end up multiplying 3 different measurements together. So when calculating the volume of a shape, all the measurements must be in the same units, just like every other time and every other shape that we have. So we'll start off with a cuboid to begin with. So all the units here are the same. To find the volume, we start with figuring out the area of the shape. So the formula for volume of a cuboid is base times height times width. Because technically, what we have, a pen, is a sort of square. I can show that very well. So we've got a square, so we know, or a rectangle. We know the formula for that is base times height. So we calculate this. So we then do 5 times 5 or 5 times 10 And then all we're doing is pulling that shape up to make it 3D. So that's why the formula volume of a cuboid is base times height, so base times height and times the width. Because we've got that flat square or rectangular shape, so we've got the base times height, and then we're pulling it up to make it a 3D shape. So in this example here, it's base times height times width, which is 10 times 5 times 5, to give us 250 centimetres cubed. The 10 times 5 is 50, times 5 is 250 centimetres cubed. And as I mentioned, it's cubed because we're multiplying 3 different measurements together. Okay? So the next one is volume of cylinder. This would definitely not come up at level 1, because as I mentioned, it does this one include a circle or a circular shape, but it could absolutely come up at level 2. So to calculate the area of to calculate the volume of the cylinder, we look at the area of the base, just like we mentioned with the cuboid, then we multiply it by the height. So all we're doing is we're taking the flat circular shape, we work out the area of the circle, and then we're pulling that shape up to make it 3D. So then we multiply it by how much we've stretched that shape up. So we know that the area, the formula, Beta's on it, the formula for the area of a circle is pi r squared. So for volume of a cylinder, it's pi r squared h, as mentioned here. So we end up with 3.14 multiplied by the radius squared, and in this case it's 5, so 5 times 5 is 25. I'll write it out though first. Then multiply that by the height, which is 20. So we end up with 3.14 multiplied by 25 multiplied by 20. Anybody want to give me an answer there? Anybody else as well? Well, yeah, centimetres cubed, absolutely, Chloe. Well done, Alessandra. Well done, Beta. Well done, everybody. So we end up with a volume of 1,570 centimetres cubed. So we worked out the area of the circle, then we pulled it up by multiplying it by the height of the cylinder. Okay. Just a couple of others for you. This is the last shape we're going to cover, and then I've got a couple of exam-style questions to show you. So to calculate the volume of a triangular prism this time. So when you see triangular prism, think Toblerone. That's the easiest way for me to remember it as well. One of my favourites. So again, we look at that shape, that base shape. When you're looking at a triangular prism, we have a triangle, which we know how to calculate the area of. And then multiplying that triangle by how much we stretch that shape out to become 3D. So the volume of a triangular prism is base times height divided by 2, because that is that triangle there. And then we multiply that by its height, going this way. This is its height. So we've got the base shape of a triangle, and then stretch it out and multiply it by its height. So base times height, as I've shown you there, we've got 3 and 4. So base times height is 3 times 4 divided by 2 to give us 6. We multiply that by the height of 6. So we end up with 6 times 6 to give us 36 centimetres cubed. And again, it's cubed because we're looking at volume. No problem. See you soon, Beta. Thanks for joining us. Is everybody okay with the volume of a triangular prism? Any questions? Hopefully, when I've explained volume, you can see that the reason why the formula is what it is, and it helps me to understand why that is the case. So you can see that base shape, you've got your triangle, and then pull it up like this. So we have the area here, and then pull that all the way up, multiply it by its height. Okay. So just a couple of questions to show you some examples from some exams. So this is an example from a level 1 non-calculator paper. It's a volume question. What is the volume of this cube? You see there the answer, the unit has been given, centimetres cubed. It's in a non-calculator paper, so it's only worth 1 mark, which most of them are in the non-calculator papers. But you'd have to calculate the volume of the cube without a calculator. You've got a simple measurement there, 10 centimetres. So it doesn't give you the formula, so you'd have to know to work out the volume of the cube is base times height times width. So 10 times 10 times 10 to get the answer. And then I've got a level 2 example. So this is a level 2 example from a calculator allowed paper at level 2. So the surface area of a sphere is 4 pi r squared. It's given you that formula because it's not expecting you to remember the surface area of a sphere. It does say use pi as 3.142, not 3.14, so just be careful. Or pi is 22 over 7, as I mentioned earlier. So work out the surface area of the sphere to the nearest centimetre squared. So you do that by working through the formula. 4 pi r squared, the sphere has a radius that measures 3 centimetres. So you'd end up with 4 times 3.142 times 3 squared, which is 9. And then you'd have an answer. I'm not going to work it out with you because you might come across this question in your practice. But this is a good example where you're given the formula for the surface area. You're told which measurement to use, which amount of pi that you're calculating with. And you're also given multiple choice answers. It's only worth 1 mark, so it's quite a calculation for 1 mark, but the fact that you're given different answers, even if you're not quite hitting the mark, you could it's to the nearest centimetre squared. So you've still got a good chance of getting that answer right, I think, with the multiple choice element there. Okay, so that's the end of today's tutorial. Does anybody have any questions at all, or want me to go through anything again? If you just put anything in the chat box, just so I know that I'm not waiting, or you're all okay, or you all have a question for me. Yes, Alessandra, you can. Just let me stop this recording a second.